Okay, we are now ready to take a look at this so-called Gaussian elimination method or algorithm. So this is a step-by-step elimination method, and it's used to get any augmented matrix into its row echelon form. We've seen in the previous part, the last video, how once we're in a row echelon form, we can get the solution, right? So once we get the augmented matrix into the row echelon form, we can get the solution to the original system. So this is simply to get the augmented matrix to be in a row echelon form. Remember row echelon form we looked at last time? You have to have a leading one, and for each row, you have to have that echelon form, row of all zeros at the bottom. All right? And we're only allowed to do, remember, these elementary row operations. Swap or interchange any two rows, multiply a row by a non-zero constant, add a multiple of one row to another. Okay? So the method that we're going to show, again, when it reduces an augmented matrix to a row echelon form, remember this is not unique, but a row echelon form, this is called Gaussian elimination, in honor of Carl Friedrich Gauss. This consists of something known as the forward phase, in which zeros are introduced below the leading ones. So we get the leading ones, and we get the zeros beneath them. And that's essentially the algorithm. That's the Gaussian elimination, to get it in row echelon form. If we continue this algorithm, however, and add a backward phase in which we get zeros above the leading ones, right, that means we're going to get into our reduced row echelon form. Okay, the procedure that uses both forward and backward phases to put the matrix in the reduced row echelon form is known as Gaussian Jordan elimination. And that's Gauss and also this German engineer by the name of Wilhelm Jordan. He gets his name into the hat, so to speak. And so we have these two methods. Basically, the Gauss-Jordan is just a continuation of Gaussian elimination to put the matrix all the way into the reduced row echelon form. I want you to be able to do both methods. Now, when we're solving with Gaussian elimination and we get it into the row echelon form, we then get the solution by using back substitution. Okay, so we have that one further step. All right, here's the idea. The first thing is we'll have an augmented matrix. We'll have entries on here, but our goal is, first of all, is right here in the upper left corner, first row, first column, that has to be a 1. Okay, that has to be a 1. And how do we get a 1 there? Well, mainly, the first thing, if it's a non-zero entry, the algorithm actually says, let's multiply by the reciprocal. Let's multiply by the reciprocal. So if there's a 3 here, I can multiply this row by 1/3, and that becomes a 1. Okay. Another way you could do it is you could interchange two rows if there is a 1 somewhere in this first column. Let's say in the bottom row there's a 1. We can interchange the first and last rows and get that leading one up there. But sometimes in this algorithm it's preferable not to do any row interchanges if you can at all. And in fact, in the strictest sense of the algorithm, typically leading ones are introduced by multiplying by the reciprocal. Now, if this entry is zero, if this entry is 0, then what we're going to have to do is we're going to have to find a non-zero entry beneath it and interchange rows. So interchange is typically used if we have a 0 entry where we need to get a leading 1. In that case, we have to find one beneath it and interchange it. Okay, and in this first column, there should be a leading 1 somewhere. You can't have a column of all zeros. Right? That would mean there was no x1 actually any of the original equations. Okay, once we get the leading 1, either so by multiplying the row by the reciprocal of that entry, then we want to get zeros beneath that leading 1. And the way we typically do that is by adding a multiple of one row to another. This leading 1 is also called a pivot 1. We're pivoting about this. So if there's a 3 right below this 1, what we're going to do is multiply the first row by -3, the opposite of 3, and then add, right, row, add that to row 2. So -3 times row 1 added to row 2, we get a 0 there if there's a 3 here. Okay, and so on, all the way down. So we do that in order, getting the zeros all the way down. So that's our first go. Once you get the 1 with the zeros all the way down, lock it into place. You don't ever want to change those again. They should never change back from being 1, 0, 0. Okay. Now what do is we shift down to the second row, and we get a leading 1 in the to the right of that entry. okay, to the right of that entry. So here, is the ideal location. Now, there is some problems. If this entry here is non-zero, then we're going to just multiply by the reciprocal. If it is 0, we're going to have to look down here and find a non-zero entry to interchange rows to get a non-zero entry up here. But it could be possible that this entry is 0 and all the entries beneath it are 0. What if that happens? What if there's all zeros from this entry right here in the second row, second column, all the way down? Well, that means we then move to look for a leading one in the third column of the second row. We shift over one more. So it is possible for that leading one to be shifted further to the right. So we, eventually we'll hit a column that has non-zero entries, right, on or below the second row, and we can then get a leading one in that column. Once you get the leading one, what are you going to do there? You're going to get zeros beneath it, right? And you continue down, and you get that echelon form until you get to the row echelon form for the matrix. That's the idea of the algorithm. Okay. Now, let me show you how this algorithm is going to work. A couple of things. Let's look at this work. This example's worked out, but we're going to solve the system using Gaussian elimination with back substitution, and then I'm also going to do the Gaussian Jordan. So I'm going to show you the two together. Here's my system. Notice it's 4 equations in 3 unknowns, right? I have 4 equations. The unknowns are x of 1, x of 2, x of 3. Again, make sure they're all lined up, right, in the correct order. All the x of 3s are in the same, so it's lined to one over the other, all the x of 2, all the x of 1s, and then all the constants on the right side of the equation. And everyone, I hope by now, knows how to get the augmented matrix, right? So 3x of 1 plus 2x of 2 minus x of 3 equals negative 15, 5, 3, 2, 0, and so on, right? There's our augmented matrix. Okay, so what we're going to do is we're going to get what? We want a 1 here. Okay, we want a 1 here. And, it's a non-zero entry. So all I have to do is multiply row 1 by 1/3, and that will do it. Okay? And so that's what I'm going to do. And here's the notation I'm going to use. And I think I interchange. Sometimes I go the opposite way, but basically row 1 becomes 1/3 times row 1. Or sometimes I'll do 1/3 row 1, arrow row 1, indicating I'm replacing row 1 with 1/3 of that quantity. Okay? But either, some notation, this is similar, the book writes it out in a sentence, multiply row 1 by 1/3, you can do that, but you need to indicate what row operation you're doing. Okay? Now, I get my leading 1 when I do that. Of course, the other entries in row 1 are also affected, and notice I get fractions, and you should write as fractions. Don't write this as 0.667 or negative 0.333. Write the fraction form. Okay? By the way, in your calculator, you can do all of these operations, and I want you to do that. I want you to use your calculator to do the row operations. There is a handout link that I linked to in Brightspace, written by Jeff O'Connell at Olone College, and this one's for the TI-8384. I think he does one for the TI-85 and TI-85 and 86, and a couple other ones possibly. But it shows you how to do basic matrix stuff, and then how to do the various row operations. Okay, and so if you're multiplying a row by a certain quantity, this is the operation you use in the calculator to manipulate it. Okay, so definitely be using this, and I'll show you that in a second here how we do that. Let's just finish the algorithm real quick. Once we get the 1, what do? We get zeros underneath it, right? We get the 1 here, that's fixed. Now what do we got to get? Zeros underneath it. How do we do that? Well, to get a 0 here, we add what? -5 times row 1, the pivot row, added to row 2. So 5 plus a -5 is going to give me the 0. All right, so I take row 2 and add -5 times row 1 to it. So 3 plus -5 times 2/3 gives me -1/3. Over here, 0 plus -5 times -5, 0 plus 25 gives me 25. Right, so that's going to affect everything, but it gets me the 0 here. And then what? To get this to be 0, I do what? -3 times row 1 added to row 3. Gets me the 0 there. And then how do I get the 0 at this -6? I take row 4 and add it to 6 times row 1. 6 times row 1 will get a 0 there. Right? Okay. And see, it does affect, in fact, the whole thing gets zeros. There's how I get you. So you might be wondering, how do you get a row of zeros? Well, there it is. It happened. Okay, that happens. All right, but once I get that, this is locked in stone. Do not change this at all. All right. What's the next goal? Next goal is to go to the second row, get a leading one in this location. Right. Since that's non-zero, I just multiply by what? The reciprocal of -1/3 is -3. So I take row 2 and multiply it by -3. So all those entries in row 2 get multiplied by -3, and I get those values. There's my leading one. So it's set. Now what do? I get zeros underneath it. Yeah, I've already got a 0 here, so I just need to get this to be a 0. Now my pivot 1 is in the second row. So I'm going to take row 3, and I'm going to add 1 times row 2 to it. So I'm just going to take row 3 and add row 2 to it. Right? So -1 plus 1 gives me what? 0. 4 plus -11 gives me -7. 26 plus -75 gives me -49. Right? And that gives me my 0, right? So now basically all this stuff here locked into place. Don't mess with it. That's locked in stone. Now what? Go to the third row, get your leading one here. How do I get a leading one from -7? Multiply by the reciprocal, -1/7. Gives me 1 there. Okay. And at this point, I need to get zeros beneath it, but there's already zeros only beneath it. So here's my leading ones. And this is row echelon form, isn't it? Right? First non-zero entry in any row is a 1. And we got the echelon effect going on. Row of all zeros at the bottom. Okay? So Gaussian elimination is the process of getting the augmented matrix for your system of linear equations into this row echelon form. And basically we're only doing these 3 row operations, right? Interchanging 2 rows, multiplying a row by a non-zero constant, adding a multiple of one row to another. And those are the corresponding things you can do to these systems of equations. That's what we would do if we were working on a system of equations. But it's just a little bit more easier algorithm to follow when we look at the augmented matrix. Now I can do back substitution. If I rewrite these equations back out, right, this would be 1 x of 1 plus 2/3 x of 2 minus 1/3 x of 3 equals -5, and so on. There's the second equation. Third equation is just x of 3 equals 7. So I have x of 3 equals 7. If I take that value and plug it back into the first, I can solve this equation for x of 2. And if I plug x of 3 in for 7, right, in for 7 there, right, then x of 2 is equal to 2. And if I take this value of x of 3 and plug it in here, and this value for x of 2 and plug it in here, I can solve for x of 1. And my solution is -4, 2, 7. -4, 2, 7, right, in that order. X of 1, x of 2, x of 3. Okay. If we continue though, so that's Gaussian elimination with back substitution, and we get our solution. Okay. But what's Gauss-Jordan? Gauss-Jordan is continuing, not stopping here, but putting this matrix in its reduced row echelon form. So how would we do that? Now we got to get, this was the so-called forward phase where we're getting zeros below the main diagonal, below rather the leading ones. Now the backward phase is getting zeros above, right? So for instance, I can now take and eliminate, get this to be 0, right? The pivot 1 is in row 2. So I can take -2/3 times row 2, add that to row 1, and that will get me a 0 here. Notice it won't affect my leading 1, right? I'll still have my leading 1. Right? It might affect these entries over here, but it will get me a 0 here, right? So if I take -2/3 times row 2 and add it to row 1, that'll give me a 0 here. Of course, if I do -1/3 and -2/3 times -11, which will give me +7. And so on, right? So I get these new entries in this first row. But there's my 0. Now what I want to get this to be 0. How do I do that? Well, now my pivot 1 is in the third row. So the opposite of 7 is -7. Take -7 times row 3, add that to row 1. That'll get me the 0 I need there. And then how do I get rid of this -11? Pivot 1 is in the third row. I'm going to do 11 times row 3, added to row 2, and that will get me the 0 over there. So now what am I in? Reduced row echelon form. And you can quickly get the solution, right? X of 1 equals -4, x of 2 equals 2, x of 3 equals 7. There it is. Okay. Now, one thing you want to make sure is you do these procedures with a calculator, okay? Because it's so easy to make simple mistakes, and one little number off in the process trickles down to the whole thing, okay? So I'm going to show you an example with the calculator, and we'll go through the whole thing. So let's do an example using Gaussian Jordan elimination, okay? This is a system of 3 equations in 5 unknowns. Okay. So first thing is to write out the augmented matrix. I'll do that. So we got 5, 2, 1, -10, -4, -2. Be very careful, by the way. This is where we often make the mistakes, which causes a lot of grief later. So we've got 5, 2, 1, -10, -4, -2. Here I got 1, 0, 0. I'm just going each column. 1, 1, 0, 15, 7, 3, and 10, 7, 1. So again, 5 unknowns. That gives me 6 columns, right? The unknowns plus this constant. So that's 1, 2, 3, 4, 5, 6, and then 3 equations, 3 rows. And just, 5x1 minus 10x2 plus x3 plus x4 plus 15x5 equals 10, and so on. Just double check and make sure you've entered these things in correctly. Okay, so in the calculator we're going to be using, let's show you how to do that. To get to matrices, let's turn it on. To get to matrices, we do matrices is right above the x inverse key here. So do second and matrix, and that will bring up this. And we want to go to edit, so you got names, scroll over math, scroll to the right, edit. And I want to do edit. I want to edit this matrix. Now you may or may not have anything in here. You might have numbers here, or you may not have. You've never used them, but that's okay. Just type 1 or hit enter, and this will be matrix A. The first number is the number of rows. Okay, so in this case, how many rows do I have? I have 1, 2, 3. So 3, you can just hit enter since there's a 3 already, or you can type 3 and then enter. You do have to hit enter to jump to the next number. Next number is columns. How many columns do we have? 1, 2, 3, 4, 5, 6. So type 6 and hit enter. Now you'll come down to the first entry in the matrix, and you want to just enter in that first entry, which is type in 5. Notice it types it down here. To get it to go there, hit enter. Notice it enters 5, and then it jumps to the next one. So then you do -10, and make sure you do -10 with the little -10, right? -10. That gives you that down there. Hit enter, and it goes into that space and slides over. Then we have a 1, enter, 1, enter, 15, enter, 10. And then notice what happens when I enter that. It shifts down to the second row. It goes down to the second row, first column. So that's a 2, enter, -4, enter, 0, enter, 1, enter, 7, enter, 7, enter. And then down to the third row, 1, and so on. Okay, so again, do you think it's easy to make a little mistake there? Yeah, so be real careful, double check the numbers in the matrix that you're typing in. Take the time to just quickly check that and make sure that those were entered in correctly. Otherwise, you'll be sorry. Okay, so I need to get a leading 1 here. How can I do that? Well, what I'm going to do is multiply by the reciprocal. The reciprocal of 5 is what? 1/5. So I'm going to take Here's one way of doing the notation. 1/5 times row 1, and I'm going to replace row 1 with that result. Okay. Now some of you might have said, hey, look down here. If I go down here, there's a 1 here. I could have interchanged rows 1 and 3 to get a leading 1 up here. Yeah, you could have done that as well. That's possible. Okay. I'm going to do it this way, though, just to show you then in the calculator how we do that operation. Okay. Well, first of all, let's exit out by doing quit. Second quit. Let's get out of the matrix. And let me just go back into the matrix, second matrix, and now just here under names, type 1 or hit enter and copy A to your screen and just hit enter. This is your matrix. You can scroll to the right and left and see everything. This is the matrix that we have. And I want to show you something. When I hit enter, that stored it in something called the answer. I don't know if you're familiar with ANS or answer right here above the little negative sign. If I do second ANS, second answer, and what is that? Hit enter. That is the matrix. Anytime, in fact, every time you hit enter, this variable ANS is updated with that result. So it's going to be that matrix. And that'll be important here, because what we're going to do is we're going to go to our commands, and I'm going to again show you this sheet by Jeff O'Connell here, and it shows the syntax. So what we're doing here is multiplying a row. So if I want to multiply row 3 by 4, we put the multiplier 4 first, then comma what? The matrix, okay, and then comma what? The row we're multiplying by. And so here's the command, asterisk row means multiply a row. Where do we see that? Well, we go to second matrix, over to math, and I'm going to go all the way to the bottom. I actually push up, the up arrow to get to the bottom, and it's E in my case, so it's asterisk row. That means multiply a row. So hit enter, and remember the syntax. The first is the multiplier. What's our multiplier? It's 1/5. Okay. You can do 0.2. I'm going to do 1/5, 1 divided by 5, comma, which is right above the 7 key. The comma is right above the 7 key. And then what? The matrix, right? Here it was matrix A, and ours was matrix A too, but remember, answer has the value of our matrix stored in it. So I'm just going to do second answer. And then comma, what's the row number I'm multiplying by? Row 1. Okay. Now, close parentheses. Now you could hit enter. That will give the result. However, when I multiply by 1/5, like 1/5, those are going to be fractions. I mean, 1/5 will be 0.2. But in general, I want to see the fraction, especially if like it's 1/3 or 2/7. You want to write that as a fraction, not an approximation. So I'm just going to show you one other important key under math. Under math, the first option, convert to fraction, arrow fraction, convert to fraction. Hit enter, tag that on to the end. It will convert your answers in the matrix to fraction form. Now hit enter. Okay, and you see that gives me a 1 right there. Okay, it also affects the other entries along that first row. The entries in the second and third row are the same. I'm just going to recopy this down. And then scroll to the right to see everything else. I've got a 3 and a 2. Okay, so there's that. Now, what do? We got our leading 1. What do we do now? Remember, zeros underneath. Zeros underneath. So how do I get a 0 here? Well, I'm going to multiply the pivot row 1. So I'm going to take row 2 and I'm going to add what? The opposite of 2 is negative 2 times row 1. And I'm going to replace row 2 with that result. And then I'm also going to adjust row 3 by adding what? The opposite of 1 is negative 1. So I'm going to do negative 1 times row 1. And I'm going to replace row 3 with that. I'm taking row 3 and subtracting row 1 from it, essentially. It's the same thing. Now, you can do 2 row operations on a single step as long as you're doing it 2 different rows. So here I'm affecting row 2, here I'm affecting row 3. Okay, we're not affecting row 1 actually, even though we're multiplying here. We're not changing row 1 actually. So how do we do that? The command for adding a multiple of one row to another is asterisk row plus. And if I'm doing negative 4 times row 1 added to row 2, I do the multiplier first, negative 4, comma the matrix, comma, the row we're multiplying, which is row 1, and then the row we're adding it to, row 2. And of course, row 2 gets replaced with this new result. That's the way it has to work. Okay. So where do we get that? Go to second matrix, over to math, go down to the bottom, and it's the very last one in my calculator, right there. So hit enter. What's our multiplier for the first one? We're multiplying row 1 by -2. So multiplier first, comma, the matrix, which is answer. Notice it's going to be answer every time, because every time I hit enter, answer is getting updated with this new matrix. Okay. What row am I multiplying? Comma, row 1. What row am I adding it to? Row 2. Okay. Close that parentheses, and then don't forget, under math, press the math button and pull in that convert to fraction. Okay. Hit enter. And there's our 0 that we were trying to get, right? We were trying to make that 2 into a 0, and there it is. Of course, it did affect everything on the second row, because we added, right, -2 times the row 1 to that second row. Okay, now here's the fun part. We want to, then I'm going to go and do, before I write down, go and do this second one where we get a 1 here, which was to take, what, -1 times row 1 and add it to row 3. The way to do that now is actually you do second entry. If you've never used the entry command, very powerful. Second entry pulls back up your last thing you entered. And if you hit second entry again, it will go back to the previous one, and so on. I think it stores like your last 10 commands. Okay, so we go ahead and edit this now, right? We edit it. What are we multiplying by now? Not -2, but -1, and we're multiplying row 1. You know, answer is still the same. Answer is the same because now it's updated with this new matrix, right? The answer is this new matrix, which is the one we want to work on. Multiplying row 1, and we're adding it to row 3. So there's the syntax. Again, please print out that sheet from Jeff O'Connell. Have that handy. That'll be very useful for you. Okay, convert to fractions. We got everything there. There it is. There's that 0 that we wanted to get. So we've got our leading one and zeros beneath that. So we can now write our matrix out. There's the one with the zeros underneath it. Second column, third column, scroll over 1/4 column, and then these last two. Okay. So this is locked in stone, right? This is locked in stone, this first column. Now we got our leading one with zeros underneath. Now we go to the second row, and let's get our leading one here. Okay, this is a 0. I can't get a leading one here. So what do we have to do? We have to find a leading, something that's non-zero beneath it to swap, but there isn't. Right? So there is not going to be a leading one in the second column. There's not going to be a leading one in the second column. Can't have a leading one here. So what do? We go further over here. Right? This becomes a 1. How do I get that to become a 1? How do I get that to become a 1? I'm going to multiply row 2 by the reciprocal of -2/5. So I'm going to do negative what? Reciprocal of 2/5, 5/2 times row 2 and replace row 2 with that. Okay. So let's go into the calculator to do that. I'm going to do second entry 3 times to get back to where I multiplied by a row. Remember, this is the first time when I multiplied row 1 at the very beginning by 1/5. I'm just going to edit that now. My multiplier is now -5 divided by, I'm about to overtype that comma, so I'm going to go second INS, that insert mode. Notice your cursor changes from a block to an underscore. Now when I type the 2, notice that comma will move to the right. It inserts it. If I move my arrow keys now, it turns it back to a block, and now I'm type over mode. Okay, so you can get in and out of that insert mode by toggling with that as well. Okay, -5/2. Answer is the matrix, right? And then I'm multiplying that -5/2 times row 2. Row 2. Still convert to fraction. I'll hit enter, and that has become a 1 now. That has become a 1. Okay. So I'll write out this real quick. First two columns unaffected. Here's my 1. And then the last two, the last 3 columns rather. Yep. Okay. So I got my 1 there. Now what do I need to do? I get zeros underneath it, right? So I need a 0 here. So what do I do? How do I get zeros? Add a multiple of one row to another. So I want to take row 3. I want to get a 0 right there. So I'm going to add to it what the the opposite rather, negative 1/5 is positive 1/5 times what row? Row 2, where I have that pivot 1. So multiply row 2 by 1/5. So negative 1/5 plus 1/5 will make that 0. And I'm going to replace row 3 with that result. Okay. So I'm going to do second entry and second entry again. So I'm going to edit now this thing, which says my multiplier is 1/5. So 1 divided by insert 5. Answer is the matrix, and I'm multiplying row 2. And I'm adding that to row 3. Okay. So hit enter, and there's my 0. There's my 0. Okay. So far so good. Now what we have to do is get this to become a leading 1. Alright, so we got our leading 1 here, lock it in, can't get 1 here. So basically we lock in all this stuff right here. This is all locked in now. So I want to mess with that. So we get down to the third row and we want a leading 1, so right there. So how am I going to do that? I'm going to multiply row 3 by the reciprocal of negative 1/2, which is negative 2 times row 3, and replace row 3 with that result. Okay. And again, it's pretty easy to do. You can do that, but again, I do it in the calculator because you may be doing other things. So I just want to multiply negative 2. Let's delete a couple of those times row 3. Right, negative 2 times row 3. There it is, and hit enter, and that gives me the entries. The only thing that really changed down there is those changes as we knew they would. Okay. Now, this right here, here's my leading 1s. Circle them real quick. Right. This is row echelon form. This is row echelon form. But what we're doing, if you remember, this is we're doing Gauss Jordan elimination. Okay. So I want to continue on and get the backward phase where I get the leading, get zeros above the leading 1s. Get zeros above the leading 1s. Okay. I'm actually going to get zeros above this leading 1. I'm going to work kind of left to right. Now I'm going to work right to left. I'm going to get zeros above this leading 1. So how do I get zeros up here? Well, I can take row 1, right? Get a 0 here and add what? The pivot row is now row 3. That's where my leading 1 is. So what's the opposite of 1/5? Negative 1/5 times row 3, and replace row 1 with that. And then how do I get this to be 0? Take row 2, the opposite of negative 3/2 is positive 3/2 times row 3, and replace row 2 with that. that will get zeros above that leading 1. Okay. So I'm going to do those two operations. So do second entry. Let me edit that. First one, the multiplier is -1/5, so I want to insert a -1/5. Answer the matrix. I'm multiplying row 3, and I'm adding that to row 1 this time. And you'll see that gives me the 0 above right that leading 1 there. And then second entry, this time 3/2. 3 divided by 2, or 1.5, right? Answer, multiplying row 3, adding it to row 2. Change that 1 to a 2, hit enter, and I get the other one to be a 0 above it. Okay, so now at this stage, we're talking about this. I did have some slight changes in the first and second row back here, though. This is 14/5, -1, 1, 1, 0, 5. Okay. And then last but not least, so again, let me just do my leading ones. Here's my leading one here, here, and here. I got zeros above this one, zeros everywhere here. I just need this entry here, right? That has to become a 0. And I get that to be 0. So I'm going to take my final operation is take row 1, and I'm going to add, the pivot row is now row 2 where that leading one is. So it's going to be -1/5, the opposite of that, times row 2, and then store that into row 1. Second entry, my multiplier is -1/5. -1/5. Answer is still the same. Multiplying row 2 this time, so row 2, and adding that to row 1. And that gives me the 0 above that leading 1. And so here is my final matrix. Okay. And this is reduced row echelon form. That's the goal that you want to get to in this process of Gauss-Jordan. We go all the way down to the reduced row echelon form. Now, okay, again, and this is what I want you to do. I want you to show each step. I want you to write these row operations that you're doing. I want you to do no more than one row operation per row on each step. So you can do multiple row operations, but they have to affect, this is affecting row 1, this is affecting row 2. You can't do two things to row 2 in the same step, or two things to row 1. That's why I can't do this one and this one in the same step. I don't want you to do that. Show clearly each step. So really looking at the understanding of this. But once we get there, what's the solution? So let's just review this again real quick, and we'll be done here. So notice again my leading ones, just circle those guys, and remember my variables x of 1, x of 2, x of 3, x of 4, x of 5. These are constants, okay? So x of 1, x of 3, and x of 4 are fixed. X of 2 and x of 5, those are free variables, right? Those are free variables. So we're going to choose x of 2 maybe to be r, parameterized, and x of 5 to be like t. Okay. I know the system is consistent. I don't have any contradictions. That would be what? All zeros and then a 1 at the end. I don't have any of that. So this is consistent. I have at least one free variable. Therefore, there's infinitely many solutions. Okay. Let's write out the form then. The first equation tells me 1x1 minus 2x2 plus 0x3 plus 0x4 plus 3x5 equals 1. Okay. Solve for x of 1. It's 2x of 2 minus 3x of 5, right? Adding 2x of 2 and subtracting. Oh, I got my 1 here. Forgot about my 1. Plus 1 plus 2x of 2 minus 3x of 5. Or what I say, x of 1 is 1 plus x of 2 is r, 2r minus 3t. Okay. Second equation says x of 3 minus x of 5 equals 0. X of 3 minus x of 5 equals 0. But x of 5 is t, so x of 3 minus t is 0, or x of 3 is equal to t. And the last equation says 1, 2, 3, x of 4 plus x of 5 is equal to 5. X of 4 plus x of 5 is equal to 5. Remember, x of 5 is t, and so if I solve for x of 4, this is 5 plus t. No, subtract. Subtract x of 5 minus x of 5 minus t. Okay. And so we're now ready to write the solution. So the solution is the ordered 5 tuple. There's 5 unknowns in this. All right. X of 1. What's x of 1? Right here. 1 plus 2r minus 3t. That's x of 1. Right, x of 1. X of 2 is what? R. X of 3, t. X of 4, 5 minus t. And x of 5, t. Right. So there's the solution in order. X of 1, x of 2, x of 3, x of 4, x of 5. There's the solution. Okay, that's how you should write the solution. Okay, so we have one more video to look at. We're going to investigate a little bit thoroughly about the so-called homogeneous systems of linear equations. Talk about those a little bit. Remember, those are ones where the constants are all 0. Okay, so that's some examples, but of course you'll need to practice those as well on your own.